if you've been a long-time QGIS user, you've been used to doing work in QGIS in different ways. Maybe you had, when you wanted to do some analysis, you were using a plugin, and the plugin did some work which was not part of QGIS. Or there was a menu, vector menu that you can use to do some vector analysis. There was a raster menu where there's some raster tools. All of this is gone. QGIS now has a centralized place where all the analytical tools are stored and are accessible. Even if you install a plugin, the plugin will add tools to those toolbox. And the toolbox is literally hundreds of tools that work with each other very nicely to build models. And this is the recommended way of doing analysis in QGIS. So we learn about processing toolbox. We're going to solve a problem. So this is a problem where we'll take some data and do some analysis. This problem is something that many of you can solve, but I'm going to show you what is the most effective way to solve this and how you can use the processing toolbox to solve that. So from QGIS, you can open the processing toolbox from the processing menu. So let's go to processing and open the toolbox. The toolbox is organized here by different categories of tools. There are also tools which start with this Q icon. These are the tools that are developed by the QGIS team and shipped with the QGIS versions. So everybody who installs QGIS, they have those tools. There are also other tools that come from plugins. So for example, this is a set of tools that were added by the plugin called ORS tools. So if you add plugins, they may also add tools to your toolbox. There's a search box, so you don't need to remember the tool's name. You can just use the search box to find the tool that you need. If you build a model or workflow, those all show up in your toolbox. And the idea of the toolbox is all the tools are designed in a similar way. They have the same interface, they interoperate with each other. That means if you solve a problem using the toolbox, you'll be able to use this to build models or to automate your workflows. Let me explain the problem. From your data package, let's load this data so that we have this file called karnataka.gpackage. This is the geo package file containing multiple layers. So expand this. GeoPackage is a modern data format similar to a geo database, but it's an open source format. It's also the default format for QGIS. You'll see how powerful the format is. QGIS really makes full use of this data format. This is the file-based format where you can store multiple data layers in a single file. It's also backed by a database, so it has spatial index and all the querying stuff the database provides, and you just have a file. So all of this thing is just available in a single file. You can put multiple data layers inside of that. In this case, we have this 3 data layers. We're going to load this layer. So go ahead and drag and drop this layer into QGIS. This is layer containing roads data for one large state in India. These roads are downloaded from OpenStreetMap. It's also a fairly large layer. So if I right click and say show feature count, you'll see that there are about 42,000 road segments that are part of this layer. And I want to open the attribute table. So I can right click and open the attribute table to see the data attributes. Or since we are now becoming advanced users, let's learn some shortcuts. To open the attribute table, this is a very common thing that you want to do after loading a layer. F6 is the keyboard shortcut. So F6 will allow you to open the attribute table. So try to get used to the shortcut. It'll save you a lot of time as you are working with data. Just select the layer, F6 will open the attribute table. So here, this data comes from OpenStreetMap. The problem that we want to solve is, I have this data layer. I was working on a problem where I wanted to know what is the total length of national highways in the state. And I wanted to get the answer for myself. So I said, let's download this data. We have this data. Each of this road segment has this column called ref, which has some information about whether this road segment is a national highway starting with NH or state highway, which is SH. So I want to extract first all the segments which are national highways, and I want to compute what is the total length of national highways in the state. Simple enough problem, but let's see how we can solve it. So let's work on this step by step. First step, how do I select and create a new layer of all the road segments where this ref column starts with NH? I only want to extract the national highways first. So how would you do this? What would be your way to do this? The preferred way and the more kind of scalable way is to use the toolbox to do all the work. There's a tool called extract by, and there are a bunch of tools here which are called extract by. That means you can do a query and directly create a new layer based on the results of this query. So first, I'm going to show you a few tools and a few things, then you can run it on your own. First, let's run this tool, extract by attribute. This is the tool, how the tool looks like. All the processing tools have the same interface where you have some configuration options here. You have the documentation right here, so you know how the tool works. We can select the input layer, which will be the roads layer. We can say the ref column begins with NH, right? So we can configure the down, extract all the features where the ref column begins with NH. And the default output is to create temporary layer. If you've been using QGIS, you generally have this problem that you have your files, your computer cluttered with a lot of intermediate files that you say, I'm doing this analysis. Typical GIS workflow involves creating at least 10 or 20 intermediate outputs, and all of those are saved on a computer, which you don't need. So the default is to create a temporary layer, which will go away when you close QGIS. Also, this is a best practice because when you are doing data analysis, many times you do not have access even to modify your source data. You are loading it from a database or from some internet service where you don't have access to modify the data. So always the default workflow in QGIS is to read the data, can extract the stuff you need in the new layer, and you can do a temporary layer. So I'm going to just run this. And you can see the tool gave me an output and say, I did it in half a second, finished. And I can close it, and you can see there's a new layer that has been loaded here. I can check, and now there are 3,000 features out of 40,000 that were selected. F6 again to see the attribute table, and you can see now all the ref columns attributes are NH. So now I have a layer of national highways in the state. And you can see this shows the national highway network. So this is one way where you can directly query and extract the features. Whenever you have some attribute queries, do use this tool. This will help you extract the stuff better. I'm going to show you different ways of doing this. This is a simple query where you say, I want to write a simple expression where it starts with NH. We can also do this using this another tool called extract by expressions. So let me show you this. You can open this tool. My input will be the same layer, the roads. And here we have the place to write expressions. Everywhere in QGIS, you'll see this icon. This opens up the expression editor. You can write expressions on data at different places. You can use expressions for analysis. You can use expressions for cartography. Here, all of the expressions are written like this. The way this expression works is when you write an expression, it'll be evaluated against each feature. If it's true, that means it matches, the feature will be selected. If it's false, it'll be discarded. Okay? So let's write an expression to do the same thing. In the expression editor, you can see there's a section here, fields and values. Here we have all the columns from our data set. I double click here, and you can see it loads this ref column in my expression. In QGIS, double quotes refer to columns. That means if you put any text in double quotes, it will be replaced by the value of the attribute from the feature. Single quotes refer to text. So here we have this ref column. Wherever it's done, it'll say the value of ref for this feature is whatever, this NH378, and it'll use that. Since we have some text, let's look at some text functions that QGIS provides. So I'm going to open up the string section. These are all the functions that are there in the expression editor, and we're going to use this function substring. So the idea here is we'll say whatever is the text there, extract the first two characters, check if they are equal to NH, and we'll extract those. So we can construct an expression that checks for the first two letters. So here, this is the function. So if I want to run this function, I can just type it, or I can just double click here and say, okay, I've entered the function. This function takes 3 parameters. What is the text that you want to extract the substring from, the start, and the length of the characters. So here again, there's documentation here. You can say the integer representing the start position. So you say start at the first character and extract a string of length 2 characters. So we have now this function will now extract the first 2 characters of the text that is contained in the ref column. And we can say this should be equal to NH. Here, NH is the text. So that means I've quoted in single quotes. Double quotes is the value of the column. Click OK. So this is the expression. Let's run this. And I get some output here, same answer. I get exact same 3,119 features which matched that expression. So I could do this 2 ways. I could either run this extract by attribute tool, or I could write an expression. And both of these are fine. Expressions gives you more power and more control over how exactly you want to match the string. I want to show you one more very powerful function that is available in QGIS expressions. So let's just do one final one, and then you can try this on a computer. We have our ref column, and the ref column has many different types of national highways. So let me just cancel this. So you can see there are a lot of different structure of the national highways. Some of them have just numbers, some of them have character at the end. What if you want to match a specific set of national highways? Let's say I want to match all the national highways which end with A. Right? And that becomes suddenly difficult. It starts with NH, ends with A, or starts with NH, ends with any character. Or you can say starts with NH, it has to be a 3-letter number in between. And now this becomes a more complex data processing problem. If you have a complex problem like this, the expression engine has another function which is quite helpful. So I'm going to show you how we can do that. So now we take our ref column. I'm going to show you this function under the string section, which is called regex match. Regex stands for regular expression. This regular expression is a technique widely used in programming in databases to match string that match a pattern. So instead of describing first 2 characters, last 2 characters, you can describe a pattern. And once you describe the pattern, you'll find the pattern in your data set. Regular expressions are itself quite complicated language in itself. Once you learn this, though, it'll give you a lot of power to do this. In your course material, I have linked to this tutorial that shows you how to use regular expressions. Let me briefly introduce you. I'm not going to cover everything about regular expression. I'm just going to point you that this exists. This will help you solve so many problems when you work with data. And GIS data is typically messy. You have, maybe your city spelled 5 different ways. How do you match all of this? So you'll allow it to do data processing here. A regular expression is, again, a standardized language. There are some kind of patterns that you can use. The main pattern that you want to use is this start and end. So if you have a pattern, it says caret the, that means it should have this characters at the beginning of the string. Similarly, if you have dollar, it says this should be at the end of the string. And this allows you to match stuff at the beginning or at the end. So now we have to match stuff that is, starts with NH. We say caret NH, and we'll match stuff at the beginning. Or if you say, I want to match something at the end, so you can say $8. That means all the stuff that ends with A. You can also do match characters which are A to Z, or a set of characters and so on. So refer to this tutorial, but I'm going to go and build a regular expression to solve our problem. So we can say regex match, and this is my string, and I want to describe a regex saying that caret NH, that is match any string which starts with NH. And now it's going to match all of those characters. So let's run this. So I'm going to run this on the major roads. Run this again here, and you have your final answer here. Again, we did it 3 ways. All of the 3, we were able to extract the national highways from the dataset. So let's try this out. We'll do this using the regular expression. So I'm going to remove these layers, go and find the extract by expression tool from a processing toolbox, run it on the Karnataka major roads layer, and the regular expression that you want to use is this here. You can also copy paste, or you can build it in the expression editor. So try this out. This is in step 5 of our first section. And once the layer is loaded, you can right click and show feature count. Regular expressions are really powerful, but they can be a bit of dark arts, right? Every programmer has their own way of doing regular expressions. Sometimes they can be very complex. Good news for all of you is that ChatGPT is very good at writing regular expressions. So next time you want to create a regular expression, just use ChatGPT. I'm going to show you how to prompt ChatGPT to write your regular expression. So we can say, write regular expression to extract string that starts with NH and ends with any characters from A to Z. And you can see it wrote a regular expression for us. And you can use this. You can also say, I want to write a regular expression that has this and has any number of other characters. And it kind of creates these expressions. So now you can use ChatGPT to create your regular expressions. Once you understand the basics, it'll be easy to kind of for you to take this and plug it in. And this next time you're faced with the challenge of kind of extracting a subset or matching set of strings, do take help of ChatGPT and the tutorial that I've linked here. Okay, so we have our national highways. Our goal for this exercise is to compute the total length of national highways. Now we have this set of national highways. How do I compute the length of all of the roads? So I'm going to introduce you to this tool called Add Geometry Attributes. This is a tool that allows you to do different computation based on the type of geometry. So it allows, if you have a line layer, it'll compute the length of the lines. If you have a polygon layer, it'll compute the area and perimeter. If it's a point layer, it'll give you the X and Y coordinates of that line as attributes. For line lengths, it says, how do you want to compute the length? So you can see our data set. This one is in the CRS 4326. So the unit of the CRS is degrees. That means if you just say, give me the length of this line, it'll give you some number in degrees, which is not correct. You do not want to compute the length, any length in degrees, because degrees are not a constant unit of measurements. 1 degree at equator is very different than 1 degree at 30-degree latitude. So do not use degrees. What's the other option? QGIS now supports ellipsoidal calculation for all of your computations. That means now you can say my Earth is not a perfect sphere, it is an ellipsoid. You can choose the model, the default model it uses is the WJS80 for ellipsoid. And now it uses ellipsoidal computation to give you the accurate length of the line or polygon on an ellipsoid. So this will be the most accurate one. If your data is in a projected CRS, you're using UTM or some other projected CRS, you can just use the project or layer CRS. So you can specify how you want the lengths to be computed. But if your data is in a geographic CRS in lat long, ellipsoidal will give you the most accurate answer. So let's run this. So I'm going to select the input layer as matching features. The length method will be ellipsoidal. I'm just going to run this. And one of the things you start noticing is one, all the tools behave very similarly. You get a nice progress bar. You get a nice log of what happened. And again, they are very fast. So compared to how you do other things, this will feel much faster because all the tools that are written in the processing toolbox are heavily optimized. Most of them are written in C++. They are multi-threaded. That means if you have a very powerful CPU, it's going to use all the cores of your CPU. And also they are kind of well-tested and well-integrated. Let's see the results. Select the add geometry for layer, F6. And now you can see there is a column called length that is added here. And when you use the ellipsoidal calculation, your answer will be in meters. So this is the length in meters for all of the road segments. We want to compute the length in kilometers. So let's just add one more column to this data. And we'll take this, divide by 1,000. So we get the answer in kilometers. So let's say we want to add a new field to our attribute table where we convert this into kilometers. So to do this, many of you would reach out for this button, field calculator. Stop doing this. Instead, search for the field calculator here. This is a modern version of the field calculator that is available in the processing toolbox. Also, that means you can run this as part of your processing workflows. And all of those are accessible here. So let's open the field calculator. The input would be this layer, added geom info. We want to add a new field called length underscore kilometers. So let's say a new field will be length underscore kilometers. And we write an expression. So this is the same expression engine that is available to you here in the field calculator. We have a field here. So I'm going to go and find my field here, which is the length. Again, you can see the length is double quoted. So that means the value will be replaced by the actual value of length from that field. And we just said /1000. This is just divide by 1,000. We will also see a preview of the result here. So that means you can say for the first feature, what was the value? And so value was 2957. When I divide by 1,000, you can see the preview. So this is a quick way to check if your expression is correct or not. And again, we leave everything else as default. This is still not a final answer. So we're not going to save this yet. Okay, I'm going to run this. And you should see a new layer called calculated. F6 to open the attribute table to verify our results. And you can see it should have a new column, length kilometer, which will have the length in kilometer. We are almost there. We almost have our answer. We now know the length of each national highway in the state. all that is left is to sum up everything and say, what is the total length of national highways in the state? Well, how do we do this? There's also a tool for doing that. So if I search for statistics, there is a tool here, basic statistics for fields. This allows you to take any column and run and extract some statistics out of that. So let's run this. Here, the input layer is this calculated field that we want to compute stats on is length _ kilometers. So we're running the last tool in this workflow, the basic statistics for fields. Input is calculated, and the field to calculate statistics on is length of kilometers. We run this. This tool is generate some numbers. So you will see some output here. So you can see the results are here. The sum 8616. So that is 8616 kilometers of national highways in the state. If you're running this as a workflow, you also can see that the final output is generated in this something called results viewer. So if your output is not a layer or a table, you'll get something here in the results viewer. If I click on it, you'll see that this is an HTML file that was generated by the tool. That means if you're running as a workflow and you say, start with my geo package, you'll end up with an HTML file containing your statistics. So this also says the final statistics is 8616 kilometers of national highways within the state. So we kind of got a fairly complex workflow and got an answer, but now you know how to do this using the toolbox. This was the most efficient way of getting this answer. And also, if you want to do this repeatedly, you can now build a workflow and use this. Also, I want to rename some columns. I want to delete some columns. So at the end of your workflow, when you want to organize the data nicely and save it, you can use this tool called Refactor Fields. This is a powerhouse of a tool which allows you to change the structure of your attribute table and by renaming columns, reorganizing the columns, or deleting columns. So let's see how we can do this. So I'm going to run this tool. First, learn how this tool functions. The input to this tool is going to be the calculated layer, which is our final layer we want to save. Here is all the fields that are available to us, and here are some tools. I can select a field that I want to delete. So I don't want this code field. I can select this and click this button, delete. It's not deleting the field yet. It's just configuring the tool. So when I run it, the field will get deleted. So I just select. I can also use the shift key and select multiple layers. So I'm going to delete all of this, not this ref one, maybe one way, all of this, and I can delete this. So I want to keep all of this. FID is the internal ID of the field. OSM ID is the OpenStreetMap ID. Maybe I don't want F class as well. Just the name, ref, and the length kilometers. I can also rename the columns if I wanted. So I can just make it whatever I want and change the data type. I can also change the expression right here. So I can say, while you are writing the output layer, divide this by 1000 right here. So I can apply the expressions even when creating the data. When you're happy with this, I can say, I want to save my layer now. Don't want to keep it as a temporary layer. Where do I save it? Don't want to create a temporary layer. Next to this, there's a drop-down. We have some options. You can save it to a file. But remember, we started our data. All of our data is in this geo package called Karnataka.geo package. It's one file containing these 3 layers. It'd be nice to put our data right back into this geo package. So we don't have to manage one more file. So best practice is when you work with the data, store everything in a single geo package. And QGIS provides you with this option, save to geo package. So I'm going to say reformat my attribute table and save it to a geo package. It's going to ask me, where is your geo package? I'm going to select this geo package. If you're on Windows, it's fine. If you're on Mac or Linux and you click save, it's going to give you this ominous looking warning saying that we're going to overwrite your data. No, it's not going to do this. So ignore this. On Windows, it doesn't give this error. You can say replace, fine. It's not going to replace it. It's going to add a layer to that. We'll name our layer as national highways. So now you configure this tool saying, take our final calculated layer, delete the fields that we don't need, and finally save this into the same geo package as we have. And once you're done, you can run this. So let me show you what happens when I run this. I get this new layer called national highways. If I open the attribute table, it's a nice, clean looking attribute table. And if I go to my browser panel, you can see my geo package has one more layer now, national highways. So no clutter. I have started with one file. I still have one file, but I appended the layer that I created through my processing. And now I have those results stored there. If you want to catch up to this point, you can just look at the solutions folder and there's a project here, processing tool checkpoint 1. So just load this one and you'll be at this stage. So you will have this national highways layer that we just created into the geo package. So before doing the challenge, you can just catch up to this processing tool checkpoint 1. And then now you are ready to do the challenge, where we'll give you a challenge and you have to figure out how to do this.